All right, so we're going to go ahead and get started with our technical session 2. My name is Royce Floyd. I'm an associate professor at the University of Oklahoma in the School of Civil Engineering and Environmental Science, and one of the associate directors for the Southern Plains Transportation Center. And I have the honor of moderating this session. We have 3 exciting presentations, 2 that are going to give us kind of an update on some things that ODOT is doing, and one from one of the other university transportation centers across the country. Our first presentation is going to be tag teamed by Tara Cullum and Dr. Michael Molina. They're going to be working together on that. Tara is the Oklahoma Department of Transportation, or the Oklahoma Transportation Cabinet's Deputy Chief Innovation Officer, and she assists Joni Seymour in overseeing all of those modernization efforts. And then Michael Molina is the senior librarian for the Oklahoma Department of Transportation Library, as well as the workforce development coordinator for the Southern Plains Transportation Center. And so if Tara is in here, I'll let her take over, and I'll let her introduce when Michael's going to join.
Thank you, Dr. Floyd, for the introduction. Good afternoon. I'm not really sure. I don't see Dr. Zaman to give him a hard time. Somehow I got the slot right after lunch. So bellies are full. You're nodding off. Hopefully I won't be too boring for you. So today I want to discuss some of the things we're doing within the Office of Innovation and specifically around research. So hopefully with the presentation, we don't get a crazy screen. There we go. So one of the first things, back in January, the department revived our internal research steering committee. This is really to allow for a collaborative environment among our ODOT champions. Again, this is internal. These champions from all over the agency have firsthand knowledge on our infrastructure, issues with our system, and they have valuable insight that is definitely needed, as well as potential solutions that we can come about with. So the steering committee is designed to encourage organic conversations around concerns, issues, and possible research solutions that further the department's progress toward its ultimate goal of a safe infrastructure. Next, I wanted to kind of go over, no, I won't bore you by reading all of them, but I'm going to kind of scan through. You're going to see current research projects that the department is doing. I know it's kind of tiny font. I do have a sign-up sheet out there that you are at registration that you can put your name and email down, and if you want a copy of this, by all means, you can get that, or you can take a photo with your phone. But again, I just wanted to give kind of a look at where we're currently at with our research so that you can see those topics, see what subject areas that we are broaching currently with our SPR Part B funding. And then I also did want to go over some initiatives that we are actually doing in conjunction with federal highways. If the remote will work. There we go. So EDC, I'm sure many of you have heard about it. It's Everyday Counts, and then STIC, which is State Transportation Innovation Council. So these are going to be some projects that we're doing, and again, this is a state and federal collaboration in regards to research projects. You can see here the EDC initiatives, and we're on EDC Series 7. Enhancing performance with internally cured concrete, next generation traffic incident management, nighttime visibility for safety, and then also strategic workforce development, which we can all agree workforce is one of the biggest issues, not only within transportation, but in a lot of the different ventures. So for STIC, we have a few other ones going on. We have pilot internal curing for bridge decks, to develop a pre-apprenticeship program, developing a strategic plan and roadmap for digital delivery, and then expand utility surveying capabilities and implement consistent process for field data collection to incorporate into statewide GIS database. Say that fast 4 times. So that's just going to give you a glimpse into what we're currently looking at, where our research is headed. And the reason that I bring this up is because we're quickly approaching our federal fiscal year 26 topic statement deadline. And so what I wanted to kind of discuss is what we're going to do for this coming year. Again, this is a time for research topics to be submitted for the 26th federal fiscal year for funding. When those topic statements do come in, they go to our research group and they look at them, evaluate them, and then we'll take them to our steering committee. And then the steering committee is able to discuss them. The SMEs are able to give feedback as well, along with the ODOT champions. And then we pose it to leadership. And that is kind of the way that we've been doing it the last year, and this is what we're gonna do again for this year. So I kind of wanted to go over, again, a couple of things. We do have a new research topic statement submission form. If you scan the QR code, it will take you directly to our webpage. I know a lot of champions as well as PIs might want to have that direct link. Another thing is that submissions must be completed by an ODOT champion. And for that reason, we're all about collaboration, whether that's academia or otherwise. We're all about that collaboration when coming up with the topic statement, mulling over ideas, the how-tos, things of that nature. But we really want this to be ODOT-driven research. And for that purpose, it has to be submitted by an ODOT champion. Again, the deadline is November 30th. And then if you have any questions, you should be able to find answers on our research page. And if not, we do have Ron Kerb, Gary Hook, and then Jerry Rice as well that you can reach out to. Other than that, the big thing beyond this is, just like we've heard today, there's been a lot of discussion of basic all the way to applied research. We want to make sure that we're covering the full gamut of things, especially, getting more into the workforce aspect, AI activity, and things of that nature. So really thinking outside of the box along with that basic research as well. So I told you it'd be short and sweet. I appreciate time with y'all today. Don't hesitate to reach out if you have any questions, concerns, anything like that. By all means, that's my contact information. Wigging out again. There we go. I'm going to go ahead and throw it over to Dr. Molina.
All right, thank you. First, I want to give all of you a round of applause for sticking with us into the afternoon. I know afternoon sessions are always the funnest, so it's great to see so many folks still here after lunch with bellies full of tasty brownies. So kudos to all of you for sticking through for almost the whole day. So first off, I want to give a big thank you to Ron Kerb and Don Sullivan. They had some very kind words to say about the Oklahoma Transportation Library. And I wanted to talk to you a little bit more about the library, who we are, what we do, and how we try to work hand in hand with the Oklahoma Department of Transportation to help further research with ODOT projects, as well as work on our own research projects, because at the end of the day, we are also a research library as well. So I'm going to talk a little bit about who we are, what we have, what we do, and some of the projects that hopefully will get you excited as well about the potential opportunities. All right, so that's a little bit about us very briefly. We started life, I think, in the basement of ODOT with all of the collections and materials that the Department of Transportation used to have. Eventually, ODOT contracted with Langston University to house these collections and contract with the university to take care of all the materials that ODOT had accumulated over the years. This includes research reports, state reports from other state DOTs from across the country, reports from universities and projects and conference proceedings, like conferences and agendas like this conference you're attending here. We have so much information in our library, both physical and digital, around 18,000 items in our collection. So we started off life at Langston University, but eventually moved to the University in Oklahoma. I think Dr. Zaman can correct me, around 2013 or 2014. It's when we moved to OU. And since then, I'd like to think we've hit the ground running with new projects and things that we have come up with. So 18,000 items in our collection, a little bit about those items. Again, we have research reports, NCHRP reports from the TRB, TRR, any state government transportation related report we have a copy of, usually in physical, but also in digital as well. We try to pride ourselves on anything that we have physical in our item. We try to keep a digital backup as well. So you can search our catalog and find any item in our collection and download a PDF of it. And if we don't have a PDF, you can shoot us an email and we'll put that item at the top of the queue to make sure you have a digital version of that file. We also have historical soil surveys from every county in the state. We also have a historical map collection as well. We have a lot of history at the Oklahoma Transportation Library that is representative of ODOT's history as well. But not just history, we have a lot of cutting edge research. I think a lot of you may be wondering, in the age of Google, why do you need a library? Why do you need a librarian? But I think as much as is true for public libraries, how they've become so much more than just a place where you go and get physical books, so too as the Transportation Library becomes so much more with the resources that we offer. For a little bit of context, there used to be a state DOT library in practically every DOT in the country. I think we're down to around 20 or 25 DOT libraries left. And so we realize we are a shrinking group, and more folks are not seeing the value of a transportation library or of a library in general. I think you're seeing that culturally as well in modern society. Again, you have Google, why do you need a library? Why do you need a librarian? So hopefully we can change some minds a little bit, some hearts and minds with this presentation and what we can offer for you, maybe as a PI, maybe working for the city, for the state DOT. Like, we can do some things for you, and I'd like to talk about that. So who can use the library? Anyone, honestly, whether in the public sector, whether you're private, whether you're state, you have a stake in this library. We want to be your library. Whether you're an engineer from chemical, electrical, any type of engineer, civil, we have materials for that. And the pitch that I give to students and other folks interested in careers in transportation is, you don't have to be an engineer to get into transportation. So much of business, of law, of management, everything touches transportation. And so trying to get people excited about careers in transportation, I always say visit a library and search for transportation and then whatever adjective you want to fill in the blank. And you'd be surprised how many topics that transportation touches. I mean, you work in the field, it touches everything. And we like to say our collection is reflective of that. So no matter you work in geotechnical or materials or any other area, we have topics and information on that, curated from not only within ODOT, but from sources across the country. One other project that we've been expanding on is PE and FE exam study materials. So if you or you know someone in your office who is studying for the PE exam, we can help. Those books are expensive. Believe me, we just bought a lot, finishing out our fiscal year spending for, at the end of September. We purchased a lot more materials than what is shown in this one picture. I think we've probably doubled the quantity of PE study exam materials. So if you know someone, we have books for them. They're totally free. Come take advantage of it. We are located on the campus of the University of Oklahoma in Norman, but that doesn't mean we don't do deliveries. ODOT pays our budget, and that allows us to be able to go and do a trip to maybe an ODOT field office or wherever you are. If it's in the city, if it's in Edmond, the training center, anywhere you are in the state, we can send items and materials to you. So again, if you're studying for the exam or know someone who is, boy, do we have a lot of free books for you. So please take advantage of this great opportunity. Again, other ways on how we serve the Oklahoma Department of Transportation. If you're a PI or a researcher and you need help finding information or materials, or you have a topic in mind and want to do a lit search, what I always like to tell folks who are engineers at ODOT, especially in management, why pay an engineer's salary for them to do a search when you can pay a librarian's salary for us to do the same search for you? Maybe save a little bit of money on the side. We know the search terms, we know what to look for, and we can package it in a very nice way and send it to you. For reference, we consult with the Transportation Research Thesaurus, which is run by the Transportation Research Board. That's 10,000 or 15,000 terms of transportation metadata that they know how to search and find. And by extension, we know how to find that stuff too. So we have data banks, we have resources, we have metadata that we do searching. What I'm saying is, don't spend your time finding stuff. Reach out to us and say, hi, I need everything in the last 5 years on this topic, and we can find it for you and send it to you. And again, this is free. This is paid for by ODOT, so please take advantage of that. It is free to you to use as an employee of ODOT and as anyone who has an interest in transportation. We also do scanning, copying, and printing. Copyright allowed. If you have a material that's digital, born digital, but you want a physical copy, believe me, I know how nice it is to have a physical item in hand to turn the pages and look at something. We can print that out for you. We can even bind it for you. If you have a ratty old book with a spine that is deteriorating, guess what? We have 1,000 binder strips that we can bind that for you and make it look like new. So we are an in-house publishing. We do printing, we do binding, and essentially we take all of ODOT's research, all the latest research reports, and manufacture that into a physical item. We post it online to disseminate it, and we also produce a physical copy of that work and can send to you straight to your location. So anything that ODOT produces, we can make a copy and send to you, both physical and digital. All right, another thing, and this is a very weighty subject. I'm not going to spend a lot of time on it, though, but if there are any PIs in the room who've done a report for ODOT, odds are you may have gotten an email from me. So maybe you have a picture. You can actually put a picture to the face and start throwing tomatoes or darts at a board, because I will send you an email talking about you need your report to be Section 508 compliant. And it's a very onerous thing to do to make sure that it is accessible and compliant. What this actually means, federal regulations are coming down now where within 2 to 3 years, every single item that you post that is on a public-facing website that's funded by public funding, like an ODOT research report or a PI's report at a university, is going to need to meet Section 508 requirements. And I'm going to be the one to reach out and try to make sure that that is accomplished. Section 508 means it needs to be accessible by differently abled individuals. For example, if you're colorblind, or if you need a screen reader, or this and that, this is what we do to make sure that that document is accessible. I'm going to go over very quickly some brief examples. The pictures may be hard to see, and again, maybe we can relate that to accessibility. Maybe the images need to be larger. Again, that's a point in accessibility. A lot of folks like to do pie charts in their project reports. It shows a lot of good data, but they only use color as the main signifier of the difference between data points. What happens if you're colorblind and that color wheel where you see blue, purple, and green, it starts to look like the grayscale image, and then it's like, well, what are those data points? I can't really read that. So that's what we help with. That's how we make sure your figures and your images, they have the proper identifiers to make sure it meets Section 508 requirements. And again, it's onerous, but it's coming from the federal government, and whether you do it now or do it later, eventually you'll have to do it, and then you'll probably have to talk to me. So again, we can help you with that. We're experts in that. We're national leaders in this area, and that is one of the services that we do for ODOT. Other items that we have a website, we have a catalog, and we have a virtual library. Very quickly, I'm going to go through these. Our website, if you go to oktl.org, this is the main website that you can see latest news and updates. I think our last update was talking about OTRD. You can find quick links and resources and all sorts of cool things, and access to our catalog. Fully text searchable. There's a simple search. There's an advanced search. Again, no matter what topic you're interested in researching, you can type it in and find an item related to that. Again, 18,000 items. And we like to say, if we don't have a copy of it, then we can find someone who does. Also, during COVID, we found a lot of people couldn't visit the library, so we created a virtual library space. This is completely navigable by clicking on buttons and links to take you through a virtual tour around the library. Joni Seymour was very kind enough to record a message welcoming you to the virtual library. So if for nothing else, you should check that out to see her message. It's really awesome. So again, you can click on links, you can navigate the library, find different spaces, access resources. We have all of ODOT's research here. It's kind of a fun tool to explore the library. Also, again, we're a research library, not just focusing on publications, but doing our own research as well. And we've partnered with several different organizations, most notably the National Transportation Knowledge Network, which is an organization of all the other state DOT libraries in the country. We're also partnering with the National Transportation Library on projects, and we're also spearheading our own project with ODOT as the lead, Transportation Pooled Fund TPF 5-442. That's a lot of letters and numbers, but what that means is we've joined with 18 other states in the country, 18 other state DOTs, to figure out how do we make libraries better? How do we make bringing resources to people better? And how do we disseminate the knowledge that we currently have? I know that's very hard to read, but that shows we have $1 million in funding and 18 other states committed to this project. And so what this means, what this does for you, we have digitized thousands of items related to transportation research that was not available before. So when you have time after this meeting, go to the oktl.org and you're going to find a link for this pooled fund study, and you're going to see thousands of DOT items from New York, from Texas, from Oregon, from across the country, going back to the 1800s. Whether you're interested in current history or way back in the 1800s, you're going to find materials related to state departments of transportation. So even for current research, or if you're a history buff, it's stuff that's never been available before, but only is now because of the pooled fund. Also, we do work on LibGuides, and what a LibGuide is a topical resource of quick links on a website. Think of it like, I want to learn about what's the latest in managing research data for public access. We created a LibGuide for that of what are the latest resources? How do you access it? What's the latest practices for that? So think of it like a guide. You're interested in a topic, we've created a guide for it. So think about in your own state department of transportation, in your own organizations, what are topics you're interested in that you might like to see an online guide for? We can create that for you. We have the resources and the technical know-how. I'm telling you, put us to work. We're sitting up there, doing library work every day, and it brings us so much joy to have someone come up and say, well, I'm looking into, UHPC, for example, or I want to know about bridge design. Let us know about it. We can find the resources, we can package it, and we can create a cool LibGuide posted online for you as well. So you can visit the Oklahoma Transportation Library. We're located in Carson Engineering Center on the second floor, room 213. Our hours are 8 to 4, Monday through Friday, and you can contact us. I'm the senior librarian, Michael Molina. Katie Widman is our extraordinary librarian as well. We're a room of 2, so we work hard. We're small but mighty and like to punch above our weight. So contact myself or Katie. Our email is odot-library@ou.edu. So again, you're interested in a research project, you want to know about a topic, or want to get connected in the national scene of what other people are doing, we know folks. We know every other librarian in the country who works on this with other state DOTs. So I think I might be over my time. I do have a tendency to do that. But again, if you have any questions or want to contact me, we're always happy to help. And again, it is totally free. So your tax dollars pay for us, so might as well use it. So thank you.
Michael, you still have a little bit of time.
Perfect.
So I just wanted to have a follow-up. So I think, this pool fund that Dr. Molina talked about is participated by 18 different DOTs, state DOTs. Also, Dr. Molina is in the process of leading another pool fund, and we talk about AI. So this is another area which is very fertile for AI application, right? So I was wondering if you could share with the audience a little bit as to what you have in mind. I personally don't like bragging, but I do brag about our Oklahoma Transportation Library. As Ron Kerr indicated that we are one of the top 5 state duty-based libraries in the country. Thanks to Tara, thanks to Joni and Don and everyone else for supporting this. I think this is good. And I think our governor is happy, Tara, right, that we are on the top 5, not 10, right? So of course 5 is better than 10 in this case. So would you talk a little bit maybe for a minute? We don't want to take time from Constantine's time, but just maybe a little bit briefing as to what you have in mind with the new pool fund.
Certainly, yeah. We've heard a lot from our contacts about AI. A lot of libraries are focusing on creating large learning language models in an enclosed space using AI to make things more searchable and findable, and having like a chatbot type of person or having AI help find materials. So say you have 1,000 state DOT reports. You can put that in a closed environment and use a learning language model to set up queries and find materials. Like, say you want to ask it a question, what are all of the UHPC reports done since 1998 that focus on this specific element? And so there are libraries out there that are working on that kind of level of granularity, and we want to be a part of that and see how we can help propel that forward. So from the library perspective, AI is going to be such a powerful tool in helping find research more quickly and helping put together reviews and literature searches on those topics. So great question. Thank you.
All right, so we do have a couple more minutes for questions, if anybody has any. I can say from having worked with Michael for several years now, he is a fantastic resource as a librarian, as well as for Section 508 compliance. He is very good at those things, and so I would encourage you to take advantage of the transportation library. But also, if you have any questions, it's a great time to ask him or Tara. All right, well, if not, let's thank our speakers again. Our next speaker is Dr. Constantine Terane, who is the Associate Dean for Research and Graduate Programs at the University of Texas, Rio Grande Valley. He is also the Director of the University Transportation Center for Railway Safety, which is a consortium of 3 institutions, the University of Texas, Rio Grande Valley, Texas A&M, and University of Nebraska-Lincoln, who is working to improve railway safety through student engagement, research, workforce development, and community outreach. So please welcome Dr. Constantine.
Okay. Just a correction. We're a consortium of 6 universities. I think that bios from the previous time. I just don't want our partners to think that I'm not acknowledging them. I'm hoping you had a good lunch, right? I'm gonna try and wake you up, make sure that, hey, nobody falls asleep. How many of you are familiar with rail? Okay, well, that's good. So I'm gonna give you a crash course on condition monitoring for rail, okay? Hopefully after this, you'll be experts. Let's see here. Okay, so I'm gonna skip outlines and all of that, just hit the ground running. So right now, the way we monitor our wheels, bearings, and track is all what we call wayside detection systems. So these are systems that are located at specific locations, some of it every 15 miles, some of it every 10, some of it up to 40 miles, depending on location. And they're just singular piece of equipment that monitors everything that passes through. So we have hotbox detectors. There's about like 8,000, even 10,000 around in North America. They're very common, okay? They call them hotbox detectors, okay? I call them hot bearing detectors, and I'll show you why. Then we have acoustic bearing detectors. These are like microphones at the side of the road that listen as trains go by, and they can determine what we call growlers, which is bearings that are really defective and produce a growling noise. And of course, while detectors, which detect the wheel impacts to detect like bad wheels. So these are the most common ways of doing bearing condition monitoring. Now, derailments, in train derailments or bearing train derailments have gone down a lot since the early 1970s, okay? And you can see the blue line and the orange, what they represent. Blue is journal bearings, okay? So journal bearings, in the past, we used to have just a axle that was rotating in a sleeve, and grease all around it. They used to call it journal bearing. Journal bearings, the mode of failure, as you can tell, when the grease depletes, there is friction, gets hot, smokes, right? And so heat is the indication of that failure. And so when hot box detectors came, that's what they were looking for, heat. Now, the orange is when we introduced taper roller bearings. Taper roller bearings are a totally different animal than journal bearings. Taper roller bearings are very efficient, and basically there's a lot of mechanical components in there, unlike the journal bearing. So there's different modes of failure than a journal bearing. And you can see that with the introduction of taper roller bearings, right, at the beginning, they had some issues called oversized cone, but then after they fixed that, they went and right now they're stabilized. Now, the railroads say that derailments have gone down or stabilized, but in reality, derailments have actually increased if you're talking about bearing derailments per trillion gross ton miles. Okay, trains have gotten bigger. Okay, and so when derailments happen, they cause serious damage. If you hit too much. Okay, so now this is just a history for what is a hot box detector. So it used to be a journal bearing, right, inside, and it was enclosed in a box, and that box would catch on fire. That's why they call it hot box detector. It was easy to spot. The hot box detectors were invented thinking of this in mind. Now, this was in the 1970s. 50 years later, we're still using that same technology to try and determine what's wrong with our bearings, even though that's not the correct way to determine damage. It's like we are insisting in making that square peg go into that round hole. And we say, no, if we push long enough, it will go in. This is what I was talking about with initially when bearings were manufactured, they had like what we call the enlarged bore size. And that used to have the bearing kind of slide on the axle, right, and create frictional heating. But then that got fixed. When that got fixed in about mid-90s, the problem went away. And so this is just to contrast like the different, what you see, the high ones were when we have journal bearings. And journal bearings, yes, they were the main way of detecting the problem was heat. And these are just the different levels of what happened with every change. So the first one, when we had journal bearings, we switched to taper roller bearings. It went down. Taper roller bearings had initial manufacturing issues, but then when we fixed that, it went down, right? And now we are at that third level. Now, this here compares basically in the early we had temperature was the main indicator of defect. But now with taper roller bearings everywhere, vibration is the main indicator of defect. Yet what we have out there measures temperature. So I categorize here vibration-related defects versus temperature-related defects. And most of the defects out there are vibration-related. And so the current technology that we use to detect bearing failure or defect is something that is not really meant for how these bearings fail. So in 2005, I started this work back in 2005. And the way I started work is that a lot of the times the rail would send back bearings saying that they're hot, meaning the hot box detector or the hot bearing detector said this bearing is hot. And they would remove a lot of bearings. And when they go back to the factory, they'll open them up and they'll say, there's nothing wrong with this bearing. I don't know why you took it off, right? There was absolutely no discernible defect whatsoever. And so I got involved because the company wanted to know, like, why? What causes that heat to happen when there was no physical defect? And I found out that, well, it's vibration-induced roller misalignment. So that roller misaligns, it causes the rollers to kind of skid, creating heat, but then after that, either the train slows down or it hits a bump and realigns, and then the temperature goes away. There is absolutely nothing wrong with the bearing. It just, that happens. And so when that did, I started by putting accelerometers to try and prove that, hey, that's what's causing it. And so from that point, we started developing a sensor, an onboard sensor. And that development took about 6-7 years, where we tried almost over 50 accelerometers, and then filtering, and how do we make it so that it can actually detect the bearing and wheel, not the noise. And so it went from, that picture you saw is about 2005, 2006, and then we developed our system when we did our first UTC back in 2013, and then a private industry liked what they saw, and they came in, they licensed all our technology, and they created their first commercial product, and that product we tested. So we did a lot of testing in MXV Rail TTCI back then to make sure that, hey, we are able to identify defective bearings. In this test, it was a blind test where we had 8 total bearings, 4 of them defective. 16 bearings, 4 defective, the rest not. And my students did not know which one are defective, and their task was, hey, you'll pass your thesis if you can detect the bad bearings, right? Or else you'll stay for 2 more years. That was a motivator. So now, this is the, HUM is the industry that has licensed our technology, and we work with them. This is one of their deployed pilots. So the way it works, every bearing has one of those sensors, and it communicates with a gateway. So the data gets transmitted to the gateway transmits it through via cellular to the cloud, and then we get that data and we can share it with the customer and tell them what's wrong with their bearings. Now, what you see, the technology that we developed can detect defects as small as that little small dot, so anything that big. The AAR defect size for something that's condemnable is the one in the middle, and what acoustic bearing detectors need is something that big, 4 inches squared. So the ABDs, they need the bearing to be really bad for them to detect. This is data from the field. So what you can see here is we get that data and we can tell what is a good bearing versus a bad bearing. Okay, so a bad bearing, we developed this, what we call the bearing health index. So the bearing health index, it's kind of like a battery. It starts at 10, 10 is healthy, and every time it declines, it tells us how the bearing is degrading, right? So you can see that a good bearing, it's fine, it's holding, it's not degrading that much, whereas a bad bearing, it will decline. The same thing we do with wheels, the wheel health index. You can tell a good wheel versus a bad wheel. And that is data, vibration data that we get from the field. So this is actual data from pilot tests. And the idea here is to be proactive. So right now, all of these systems that we have are reactive. By the time you actually detect a problem, like the East Palestine derailment, the system told them the bearing is hot. It's not that it didn't tell them, but by the time it got to be above the AAR threshold and they tried to stop the train, it derailed, right? That is way too late to stop a train. Temperature, and I always say that and people, look at me strange, but I said, trying to detect defective bearing with a hot bearing detector is like trying to detect cancer with a thermometer. Will you detect a person is dying? Well, yeah, when he's about to yeah, he might get a temperature increase. That's too late. And so what we want with this is to be able to look at your vibration data and tell you you have 25,000 miles, 50,000 miles, 10,000 miles, and be able to give you enough notice so that if you're a rail company, you can say, you know what? Yeah, I know that bearing is about, well, it has 50,000 miles. 50,000 miles is, according to how I operate my train, is 10 trips. So on the 9th trip, it's going to be close to one of my facilities. I'll just go and take it out, instead of it stopping in the middle of the track and causing all kinds of issues and delays. So some of the tests that we have done, oops, this one jumps a few, there you go. So this is, let's back up one. Oh, there we go. So this is data in our lab. This is an inactive bearing. These are bearings that did not move for 3 years. So 3 years they were inactive, sitting in one of the side tracks. And we got CSX Transportation to agree to send me those to our lab for testing. Because the bearing that caused the East Palestine derailment was a bearing that sat 280 days and then 563 days inactive. So we were trying to see, NTSB wanted to know, is this a cause, right? So this is an NTSB study that we did for them. And so you can see the top is the vibration data, the bottom is the temperature data. The red line is our vibration threshold, meaning anything above that red line, it's 100% defective. We have never ever opened up a bearing with a vibration above that red line and found it to be healthy. And anything below the blue line is healthy. Anything in between blue and red is kind of getting defective, okay? Now, the red line at the bottom, the temperature, is normal bearings operating at that load and speed. The red line at the top is the AAR threshold, which is where you start removing that bearing. So now look at this bearing. The temperature never, ever reached the AAR threshold. Never. Okay, didn't even come close to the AAR threshold, which is what hotbox are supposed to read. The vibration, you could tell that the bearing started actually increasing, right? And the vibration kept on going up. Now, this bearing lost its seal. The seal popped off at 7,000 miles. So it operated 87,000 miles after the seal popped off. When we told the railroads, hey, the seal popped off, they said, hey, that bearing's not gonna run more than 2,000 miles. It ran 87,000 miles and the temperature was not even an issue. Now, so you have a healthy bearing that ran the same amount of miles because we run 4 bearings in the same axle, and then the bad bearing. Okay, there is the bad bearing. The bad bearing had so much damage. It was all over, all around, all the components, over 50% of its surface areas. It had a cracked cone. I've been testing this for 20 years. I have never, ever seen a cone crack, ever. We're talking about 20 years of testing. So imagine, this is how the bearing looked. The temperature never reached, not even normal, it didn't even exceed normal temperatures for a normal bearing. Yet the vibration was telling us it's bad. And it told us it's bad 70,000 miles before we had to pull it off. Some of the other tests we did, these are wheel sets. So that's for bearings, wheel sets. We removed wheel sets. One was healthy, one was defective because of this data. And this is the data. So you can see the healthy bearing never exceeded that green line. So that's a healthy impact. The other bearing, you could see it was saturating. So we knew it was bad. And so we removed those. Now keep in mind, this is operated by a short line that doesn't have neither wild nor HBD. So the only way they could find this is through this sensor. And when we replaced the wheels, so this is the healthy bearing. Before and after, it didn't do much. And so we were able to create a kind of trend line that tells you how a bad bearing behaves, and then we can tell if it's below the line, it's healthy, if it's above the line, it's bad. And so this way, using this data, we can actually tell you how bad your bearing is compared to a wheel that has a 2 square inch flat. So this one had a 2 square inch flat, okay, which is condemnable basically. It cannot go back in service. And again, there is this, with bearings, one of the bearings we pulled, so we talked to CSX and we said that, hey, we find that bearing right there in the green, and we asked them to remove it because we wanted to prove a point. We said our algorithms tell us that if you remove a bearing there, you still have about 50,000 miles of operation. So I just wanted to prove that that's right. So we removed it, we brought it into our lab, and we tested it. And so we tested it in our lab. When we did that, you see the temperature, again, never went up. The vibration immediately, once we increased the speed, those lines, like every time the speed increases, that threshold increases, it's speed dependent, the vibration increased. We actually ran 46,000 miles before we actually took it. We didn't take it because it failed. It was generating so much noise, it was actually ruining our sensors. It kept on breaking our sensors for so much vibration. And so that was exactly what we predicted. We predicted it would be about 50,000 miles. It ran 46,000 miles. And when we opened it up, it had all kinds of defects, okay, on all of the surfaces. So the whole bearing had, so 63% of the raceway was defective in one of the bearings. 45.6 of the raceway was defective. So almost like more than half of that was defective, even though the temperature did not show anything. So you're wondering, by the time the temperature shows something, what happens? It's ready to derail. There's no saving it. Now, this is for track. So we got lucky there because we take every 10-minute measurements. And then when we took, there was this lonesome point there. And we said, like, well, why? Did the data go bad? Is the sensor went bad? And so we went back to the rail company and we told them, hey, we have a GPS on the sensor. So we said, can you go look within 3 feet of that point? Just go 3 feet before and after. And when they did, sure enough, they found a bad spot. So it wasn't intended for this because we don't do it continuous, right? If you want to see bad track, you need to kind of, we do it every 10 minutes. It just lucked out that when we took the measurements, it was a bad point, and so we did. So this system can do wheel, bearing, and track if you're not worried about battery life. This is the team I have. We have about 90 students and five staff working in the center on different projects. Some of it is basically track, some of it is grade crossings, some of it is infrastructure, robots, AI. So we have a large team working on different things. A lot of it has a flavor of basically transportation and rail transportation. So that's our main focus. The testers we have are the only testers in the United States that are available for public. So we have a lot of, like, we have 6 companies that are basically sponsoring research just to do our testing. We provide that service for rail industry. With that, thank you, and I'll take any questions, if there's any time.
All right, we do have time for a couple of questions, if anybody has any.
I didn't understand the question. Uh-huh. I mean, the bearings, like, stopping and going does not really affect the life cycle of the bearing. What affects the life cycle of the bearing is once it starts developing a defect, that defect will continue to degrade right? Depending on the size of the defect, right? So let's say you start with something that is 0.1 inch squared. It's gonna continue to degrade. Doesn't matter, it depends on mileage, how many miles you run. So typically, if you start with a 0.1 inch squared, according to what we have done over the 20 years, it takes you about 120,000 miles for it to get to a point where it's really bad, right? It has nothing to do whether it is loaded, unloaded, you stop, you go. It just kind of, that was the math behind it. It's like about 120,000 miles. Now, what can accelerate that? If, for example, somehow the seal is compromised and grease is coming out, it's gonna accelerate that. Or if you start getting moisture into the bearing, that's gonna accelerate that. But as long as the bearing is intact, you know, that defect will, it's just mile dependence, right? And we did a lot of these modeling, and we found out it's about an average between 100 to 120,000 miles. Yes, that will not affect the bearing. Now, the bearing will be affected if you have a bad wheel, you know, that's continuously impacting. That's gonna also accelerate the defect, because the bearing will see that impact, right? But stopping and going does not really affect that bearing.
All right, we can take maybe one more question.
Anyone else would like to ask question? Well, if not, then I have a question in terms of, so we talked about AI. What type of AI model, if any, you have used with your data, and how do you know the quality of your data? Because that's another thing is really, really important. And a related question is that as you do your testing in the lab versus in the field, do you see a big difference?
Yeah, so we haven't seen any difference between lab and basically testing in the lab and in the field. The sensor has been tested in the field so much that by now we have confidence that whatever we do in the lab is similar to what happens in the field. With the AI models, what we're doing is, so the data you see, looking at the vibration and the conditions, loaded, unloaded, healthy bearing, bad bearing, we put that into the AI and we try to predict. So the idea here is, if let's say you have a bearing deployed and you're collecting that vibration data, the model should be able to look at the data, look at changes in, let's say the data is at a level 5 and all of a sudden becomes 6. Right? It looks at the time period, it looks at and starts predicting into the future, tell you at this rate, the bearing service life would be 70,000 miles, 50,000 miles. And so that information then can help railroad to decide when do I do maintenance. So those are the models we're doing, is we're looking at all of this data and trying to see what is an indicator of deterioration and how do you track it and how can you predict. So we have a lot of data to train, that's just nice. But again, these models need refining, because a lot of the times, the nice thing about it is that I always train the students and say like, look, we have this other experiment, try your model and see, does it give us? Because we actually have the data and tell you, yes, your model is good, no, your model needs more refinement. But it's still a process, and we're still at the beginning of this, because we're just starting to get a lot of data from the field. Most of our data is lab, and rail industry likes field data. They're a little bit skeptic of what you do in the lab. They say, well, the lab, it's controlled. So that's where we're working on. Thank you.
All right, let's thank Dr. Tarane. Our last speaker is Anthony Dels, who is a division engineer for the Oklahoma Department of Transportation, where he has been with ODOT since, I think, 1999. And he's going to talk to us a little bit about some ODOT recruitment programs.
I can't see over the mic. Vertically challenged. On page 7 of your program, there's a description of a guy who goes by the same name as me. I don't know that guy. That was 2014 Anthony. That was from a different multiverse. In this multiverse, in 2024, I am now the engineering development manager for the Department of Transportation. So many, many moons ago, I was the operations engineer. I say that was just last year, but I did that for a long time. back in 2014, I took that position. But today, I'm happily serving as the lead recruiter for engineers for the Department of Transportation. But let me tell you how I got here. About late summer, mid-fall of last year, the department, we experienced a lot of retirements, a lot of separations from the department, and a lot of those folks were helping us administer our engineering development program. And we found ourselves in a position where we were hurting. We needed somebody to push the buttons for us. We had lots of engineers making decisions and telling engineers where to go and how to do things, but nobody was pushing the buttons and helping us administer this thing. So we sought for a long time for somebody to step up to the plate who would do this for us and lead the charge, and we couldn't come up with anybody. And for those of you who know me well, I'm a team player, and if you need help, I'm going to step up. I'm going to be there to help you. So I reluctantly volunteered and said, you know what? I'll keep this thing running for a little while until you find somebody. That was September 2023. Here I am, still. This is October now of 2024. I've been permanently put into the position. I don't know if that's punishment or I did such a great job. I don't know, but I'm happy to do it. And so, there we go. She told me not to hit it too hard. Don't hit it too many times. That's the issue. There we go. So again, I am now the Engineer Development Program Manager for the department. And they were gracious enough, and Tara left the room where she, oh, there she is. I stole one of, Tara's employees. I'm gonna leave all the adjectives out. So I wanna thank you again for like the 15th time, and you can't have her back. All right, but Ms. Kayla Fowler, she's sitting over here. I thank her for coming and joining me today, helping with this presentation. She is the one who makes this thing go. I'm just bringing all of my experience to the position, but she has brought such innovation to new ideas, and she's everything that we knew we needed and then some. She's brought so much innovation to what we're doing and is setting us up for a great future in our program. All right, stick to your notes, Anthony, stick to your notes. Okay. So together, she and I, we've been tasked with, first of all, tending to the needs of our existing engineers that are at ODOT and in the program. We're also been tasked with increasing the numbers in our engineering workforce. And if I have any consultants out there, you know the challenge that can be trying to find good talent for your company that's going to stay, right? And that's the other part of what we've been tasked with doing, not just recruiting them, but finding a way to retain them, right? Because people like John Bowman keep stealing my people, but that's fine. Soon there will be enough to go around. So if you stick with me through this presentation, we'll tell you where we're going. Okay. So with that task, we got to work. We've hit several career fairs. We have an online presence. This is how we do most of our recruiting. But I wrote this, I'm gonna read it. This is probably the only thing I wanna read to you, so apologize, but this was good when I wrote it, so I gotta read it to you. The department continuously recruits and develops engineers in order to maintain an experienced team of engineering professionals tasked with improving and maintaining the state's transportation infrastructure. It is the goal of the engineering development program for engineers to find their unique niche within ODOT, a place where, as an ODOT employee, engineers feel valued and find job satisfaction, leading to a fulfilling, successful career in the state's transportation engineering workforce. That's what we're all about, and that's what we're doing. So our program has and always has fallen under the purview of our chief engineer. So every engineer that comes into our program has oversight of our chief at the Department of Transportation. Students or engineers can enter our program either as a student or as an engineer on rotation. And we'll talk some more about that as I go through my presentation. Once a employee enters our program, they have 7 years in our program to get their professional engineering license. And at that time, we expect them to go on and find a permanent assignment in one of our many divisions within the department. All right. And we'll talk about some more about some of the requirements as we go along. There's also opportunities. We will sometimes direct hire an engineer to a specific division. I know sometimes with somebody who has a specific niche in, say, geotech, we'll send them right to materials without having to go through the rotation experience. But those are some of the pathways into ODOT. So when we made this transition, this shift, we had a lot of pieces of our program throughout the agency. We have our rotation program. Then we also have our Engineering Development Council, known as the EDC. Then we also have teams of students at our universities are also working. We're training them how to design plans and design roads and bridges. We took all those things, we brought them under one umbrella and called that the Engineering Development Program. So all of those things now fall under one purview, and it's still underneath the chief engineer, right? So there's the chief, there's our program, and then we have all the other components that come together to make up our program. We've been given a budget. We didn't know how much it was going to be at the time, so I shot for the moon, and we just about got it. And so I've been overspending, so I can keep that number high next year. They'll whittle me down eventually. We are state government, low bid, all those things, but for right now, we're flying along with, it seems like a blank check, and I can say that because my boss is in the room. So we're having a great time, right, Kayla? And we've also got, we also have our own table of organization, right? So I'm the manager. Kayla's my assistant, and then we have the EDC that works with me, and I have about 100 engineering positions that fall beneath me. That includes students and engineers on rotation. And there's just lots of, you can imagine, lots of, I won't say turnover, but people coming in and out of the program as they graduate out and some come in. So that's the need. All 100 positions aren't always filled at the same time, but I need those to execute that transition and operate the program. Right. So ODOT, we're always hiring. And I'm looking around. I see some gray in the audience. Some of us remember what it was like to open up the newspaper and look at the classifieds and try to find jobs, and you circle the ones that you liked and you thought you're interested in, right? So I try to make it look like that, but these days it's totally different. I mean, there's no such thing even as a newspaper anymore, really. But we have a presence, right? We have an online presence. We have a presence at the universities. We're always recruiting. There's a career fair we can get to. We're there, always recruiting engineers. The goal of the program is to hire 15 new engineers every year. I mean, that's every academic school year. So spring, fall, summer, we're looking to get 15 engineers. But we won't, I mean, we get to 15 and we still find some that we want to recruit. We won't, that's the minimum, what we're looking for. But we'll exceed that if we need to. And we're setting ourselves up as we move forward to eventually, right now, again, we're hitting all these outlets to recruit engineers, but we're setting ourselves up that our universities really are, we want that to be our farm system, if you will, our pipeline to ODOT. So at some point in time, we're going to have enough engineers coming out of the squads that we don't have to go to career fair. We just say, who's graduating this year? And we'll have the 15 and hopefully enough left over, John, that you can have a couple too. All right? That's the way this is intended to work. And any shortfalls, if we don't get that 15, then again, we have our online presence. We get applications all the time. Again, we're doing career fairs, looking for talent in our engineering workforce. Just a quick short story, and I was kind of shocked that this happened, and I'm going to kind of rib John in it a little bit. Just last week, or over the last month, we hired 3 new engineers, and they all came from the consultant workforce. Usually it's the other way around. So, gotcha. Right? But they're not coming to ODOT for the salaries, right? They're coming looking for that work-life balance that we all enjoy at 4:30. Where all my state employees at? Right? Yeah. We don't have that thing called billable hours. It's 4:30, it's time to go. We're headed out the door, we're going somewhere, right? They're coming to us, they want that. One of the guys that we hired, he said, me and my wife were expecting a baby in March. Being on the clock like that wasn't gonna work for them. We brought somebody from out of state who was looking to come here and, again, find that work-life balance. And it's an honor and a privilege. I'm proud to say we can offer anybody that who wants to come and find an engineering career within the state of Oklahoma. ODOT can offer that to you. All right. So let's talk about our university squads. This is something that's unique to ODOT. We have 2 design teams, one at OU, one at OSU, and we're training them to design roads and bridges, and we pay them a pretty decent wage. I missed the opportunity when I was in school. But again, there are ODOT university design teams. I refer to them as our ACEs, our aspiring civil engineering students. in the past, this program, we would maintain about 10 students at each university, and we would even struggle to do that. As people graduated and we're trying to get people on, trying to hit that number of 10 was a challenge, but we're getting better at it. But the goal now, and this is where I want to help you out, John, we're going to double the size of our squads. So we're going from 10 to 20, right? And so with that, hopefully, like I said, that becomes our pipeline, our bread and butter, our farm system. And so as engineers are graduating, there's plenty that are coming to the department, and being realistic and knowing that John's going to come and pluck some of them away from me, that's fine, right? That's fine. And in that sense, I'm okay with that, because I feel like now the ODOT is training the entire workforce as it applies to civil engineers in designing roads and bridges and maintaining our infrastructure. That's something that I can stick my chest out about. I feel good about that, right? So to qualify for our program, let me back up. So to get these 20, and anybody that went through the squads, you're going to be a little bit jealous. We're going to have to renovate both squads. So we're remodeling each space. So at OSU, we've got almost the entire first floor at OSU is going to be ours. And we're renovating that space to accommodate 20 plus students with staff. And we're doing the same thing at OU. We're taking that space, we're knocking down the walls, we're opening it up to, again, accommodate 20 plus students to beef up this program and to get the numbers that we're looking for. To get in, a student only needs to be 18 years or older. They must have completed 30 credit hours of schooling towards an civil engineering degree, and be able to work 20 hours a week. And to me, this is the beauty of this program. We're only asking them for 20 hours a week. Now, when they come to ODOT, they're full-time students. They're just putting in part-time hours, all right? And so because they're full-time students, they get full benefits at the salary that we're paying them at. And so at OSU, when they come to work for us in the squad, when it's time for class, they go up one flight of stairs to class. And when the class is over, they come down one flight of stairs and go back to work. You can't ask for a better work environment while you're in school, right? You've got a salary, you're getting your classes, you got your work, just 20 hours a week, you got your weekends off, and you're still off at 4:30. You can't ask for a better work environment as a student. The same thing at OU. Classes are conveniently located to where the squads are. You go back and forth to classes, and we fit your work time around your class schedule, right? So I feel a little bit for our engineering managers at the squads, because every semester they have a new challenge of working out a new schedule for everybody's class schedule, but that's just the way this thing works, all right? And it's the beauty of it. So we dare not ever take the squads off of campus. There was a rumor at one time we were going to move the squad to somewhere off of campus. That takes away from the attraction of it, right? We want you to be right there where your classes are. And it gives us some visibility on campus, right? When you go into the building, Engineering North, you can't go to anywhere without passing by the ODOT student lab. I mean, we're right there, right? And we're working on it at OU. Whereas doctors, we gotta do something. People don't know we're in there. We got to do something. I'm gonna put some yard signs up, something. We got to do something at OU to increase our visibility there, because it's that important. We have a fantastic opportunity. It bothers me when I talk to a parent, or I would talk to a student about this opportunity and they turn us down, right? If I was to tell their mother, they're like, you're going to pay my son, my daughter, how much? And they're going to get benefits. They're going to start retirement. They got time off. They can go to the doctor on their own insurance, and they're turning you down. Thank you. All my parents are laughing right now because we get it, right? They don't necessarily understand. They're wanting that job at the student union. When I'm telling you, you can work in your field that you're going to school at, get paid, get benefits, and your retirement clock starts at 20 years old. Come on. You're not going to find a better opportunity than that, right? And that was another reason why I jumped into this thing. We have to be a bigger presence so others know. And it's happening, because now at OSU, we're at capacity, right? We can't get to that 20. We got to knock down some walls, remodel, and we're at capacity with a waiting list. And even after we get knock down the walls and remodel, we're going to be able to exceed the 20 and still have some waiting to get onto the squad. That's what we want, right? And OU is quickly catching up because the word's getting out. We've got a great program. My job is easy because what we have sells itself. Once we tell them what we do and how we do it and what's at stake for them, everybody wants to be a part of this. All right, so my job is easy. It's just I have to get it out there. We just have to get it out there. And with Kayla's help, we're going to do a great job. Come on. Actually, are you 18? Talk to me when this is over. Right. Yep, went too far. Okay, so in the past, if those of you who are familiar with our squads, the OSU squad used to be known as the roadway squad, and we had at the OU squad, we used to call them the bridge squad. We've done away with that. We're doing roads and bridges at both locations now. And so right now we're in a little bit of a transition because we're learning to do the other at the other location, right? So at OSU, we're learning how to do bridges, and at OU, we're learning how to do roadway. But the intent is we're gonna teach it all at both locations. So we're developing a curriculum so that everybody's on the same pace, the same scale, learning the same things so that when they graduate, they're coming out, they're a well-rounded transportation engineer, right? And that's the goal. And these are just some of the things that they're going to be learning and we're going to be introducing them to, exposing them to while they're there. So again, bridge design and roadway design, they're going to get some CAD experience. They're going to get familiarized with some of our standards, specifications. They're going to learn file management. You wouldn't think that's a thing, but it is. We've had a couple that we hired that didn't really know how to navigate the files and where to drop something. That's a thing. So they're going to learn that and have that skill when they come to work for us or for you, John. They're going to learn plan production, right? And that's another thing. In the past we were more focused on getting out a set of plans, and now we're more focused on training them how to design, how to draft. And if they get to a point and progress to a point where their skills are good enough that we can allow them to work on some projects, then we'll do that. And then they'll get into some of the plan production. They'll get pieces of plans. They can check quantities. They can check summaries. They can check title sheets. They can do those types of things, help draft a little bit. But until that point, they're going to be in a training mode until they graduate. And as they get more advanced, we have more advanced things they can get into. We've been talking about AI all morning. If that becomes a thing, we'll get them into it. We're working on 3D modeling. That's a thing. We're going to be introducing them to that. And along with that, and I love this. This wasn't even my idea. It was the EMs at the universities who thought of this. Along with those technical skills, we're also going to be encouraging some of those other skills, leadership skills, right? We're going to be encouraging communication skills and professionalism, right? That seems to be a thing these days. I interviewed a guy 2 days ago with a cowboy hat on, virtually. See all the gray hairs looking at me like, what? That's a thing. But he was pretty good. I hired him. But it never would have crossed our minds to do my interview virtually with a cowboy hat on. So you've got to be pretty good to get by with that, and he was. So there it is. So we're trying to get to 20. We're teaching everything at the universities, and we want to have enough that we can get our 15 from our universities and have enough to share, John. You're welcome. All right. So the bread and butter of our program is, and probably always has been, the rotation. And I know many of you are familiar with that. There are other DOTs and even organizations. I've heard some firms who have adopted this model. Our rotation program is an opportunity for new engineers to come in and get exposed to everything that we do within transportation. And those are, I won't read them all, but those are the areas that we expose them to, right? The time frame on it, they come to us and they spend about 17 weeks in our central office getting exposed to the design elements of transportation. And then they spend about 15 weeks in the field as inspectors, field engineers, and in our maintenance crews, right? And that's about 9 months, right, of exposure to what it is that ODOT does. But here's the beauty of it. At the end of that 9 months, we allow that employee to come back and tell us where it is they want to work, right? We know we have needs, and we would rather you go take care of a need, but if that need doesn't fit you, that doesn't fit us. And so where it is that you found it along your rotation that you thought this works for you, that's where we want to help you get back to and start your career from there. right? Just to give you a quick story, we had an employee that I came across in the morning, came to work, we were walking across the parking lot, and we were crossing paths, and I just, hey, how's your rotation going? And if you knew, I won't give any names, but if you knew this person, she's legacy. Her dad was big in the materials world. Her mom worked in the bridge division. I mean, you would think, she's going to pick one of those two areas, and was leaning more toward the material side. But I just asked her, how's your rotation going? Which way are you leaning? And she rattled off 2 or 3 things, and that kind of caught me off guard because I wasn't expecting her to say that. And I just kind of looked at her and I was like, huh, okay. And her last comment to me was, it's good to have options. And that's what the whole point of this program is to give that employee options so that they feel that satisfaction about coming to work and who they're going to be working with, who they're going to be working for, right? And forgive me, I didn't tell you this, I'm a Pentecostal minister at heart, and so if you feel me about to say an amen every now and then, forgive me, it's just in me. I can't help it. But you can always shout back, just wave at me or pass the plate. I'll take that too. So some of our program benefits, and I may have touched on some of them, but we've developed a signing bonus for new. Did we miss you? Did you not get the bonus? You got the bonus. I didn't get the bonus. You didn't get a bonus? You got to start over with him. Talk to me when it's over. I know you didn't get a bonus, Mark. Yeah, but when they sign on with us, they get a signing bonus. There is a commitment with that, right? We just don't hand out money, don't expect something for it. But it's worth it. I mean, it's a signing bonus. We also have support to get their FE and their PE license. It amazes me anymore that students are coming out of school, graduating, haven't even thought about taking the FE. I know when I was in school, it was a weekend. It was on our calendars and we knew it. This is when we're all going to sit down and go take the FE. I guess now with the change in the format, how am I doing on time? I can talk fast. Yes, but when they come, we have support for them to go get those certifications. We have a contract with the School of PE. We keep about 25 registration licenses. All they got to do is let me know they're getting ready to study for it. We get them signed up. It doesn't cost them anything. All we require of them is that they use it. That's it. Use the program. Don't let the state waste their money, but go study, pass that exam. But we fully support them. All the resources, any books, references that they need, we'll get those too. And now I know I'm getting them for free. Where's Michael? Now I know I'm getting them for free. We're coming to you, buddy. Thank you for your presentation. Yeah, but we fully support them getting those licenses. We also offer a PE bonus. So when they do finish and pass that exam, we'll give them another bonus for doing just that. We also provide them with leadership training. We don't expect our engineers to come in and just stay at one level. We want them to move up through the ranks and become leaders within the organization. And lastly, we also have special events. I look at our each class that comes through as almost like how you rush, you have your sororities and fraternities. They come in as a class, and I try to treat them that way and make sure they go to events together, do things together, get to know one another, right? Because we're one big family, but you come in with this small little group, and so we try to make sure that we have some events where they can get together and be peers. And lastly, I'm still in on time. Mm-hmm. I'm over a little, okay. So read that. Any questions? These are just some things that we're trying to get into as we go forward. And I touched on a few of them, but we do have some outreach. Kayla's going to be overseeing our outreach to high schools and trade schools, trying to get some pipelines established there. We're also trying to get some scholarships set up to get people from our rural areas to ODOT and to our universities. So I'll shut up.